Let's continue with the back page of the morning test review from chapters 5 and 6. So number 3, match the slope field with the correct equation. So one thing that we see with the slope field is that when y is equal to 0, when x is equal to 0, we're expecting a slope of 0. And when y is equal to 0, either the slope is equal to 0 and it's covered up by the axis, or that slope is not going to exist, right? And then further, we can look for some easy order pairs here. We know 1 to 1 will produce a positive slope, negative 1 to 1 will produce a negative slope, and 1 negative 1 will produce a negative slope. So let's look at our possibilities, our choices here. When x is equal to 0, we're expecting slope of 0. So we know that b will be out, because if x is equal to 0, we should not be seeing any slopes at that point. And we know it can't be x minus y, because when x is equal to 0, we're getting a negative y. A negative y may change along these values, so we know it can't be a or d, or it can't be b or d, so it has to come down to a and c. So what we can do is we can just simply plug in an order pair and test. So I know that at 1, 1, order pair 1, 1, I have to be getting a positive slope, because that's what I see here. But if I plug in 1, 1, I'm getting a negative 1, and that is not going to match with what we know about the order pair 1, 1. So it must therefore be choice C. Okay. All right, part B, find the particular solution given our order pair 5, negative 2. So we have our differential equation, which is x over y. Okay, we begin separating the variables. So bring the y's to the left, bring the x's to the right. So we get y dy is equal to x dx. Take the integral of both sides. Power rule will apply for both sides. Y squared over 2 is equal to x squared over 2 plus c. And we can go ahead and plug in the order pair 5, negative 2, or I think what I decided to do here was to multiply everything through by 2 first, and then plug in negative 2, 5. So negative 2 squared is 4, 5 squared is 25. Subtract that from both sides, we get c is equal to negative 21. So therefore y squared is equal to x squared minus 21. Okay, now I can take the square root of both sides, so we get y is equal to plus or minus square root of x squared minus 21. But we have to choose between the positive square root or the negative square root. Now the order pair is 5, negative 2, so we have to be, when we plug in 5, we must be getting a negative value in return. So the only way that's going to happen is if we have a negative square root. Okay, part C, sketch the solution through the given point and find the domain. So we can plug this in our calculator. Y is equal to negative square root of x squared minus 21. And we know it has to go through this point, 5, negative 2. So now we simply just follow the flow of the graph. So the graph is going down to infinity. But when it goes up, it has to stop at the x-axis, because what we know about the differential equation is that y cannot be equal to 0. So the graph will go as far as y equals 0, and we have to just put an open circle there. Okay. However, so we know that the graph starts here and goes to positive infinity, okay, because it keeps going right. But we know that y is equal to 0 at this point, but domain is asking us for x value. So we know that the y value is 0, so to find the x value, we simply look at the equation, plug 0 in for y, and then solve for x. So our equation is y is equal to negative square root of x squared minus 21. Plug 0 in for y, and let's begin to solve for x. So square both sides, and we get x squared minus 21 is equal to 0. Add 21, so x is equal to plus or minus root 21. Now, this point is obviously going to be a positive x value, so we know that's going to be a positive root 21. Negative root 21 will be the other branch that we're not going to concern ourselves with because we're looking for the solution that goes through this given point 5, negative 2. So our domain will simply be the x value here, root 21 to infinity. Our open interval will be our domain. Okay, number 4, we have the integral of 2e to the x minus 2e to the negative x, all over e to the x plus e to the negative x quantity squared. We really can't split this up. We can't cancel anything out, so let's look to u substitution. And usually it'll be easier to get the u value to be in the denominator because usually it's just easier to cancel something out in the numerator. So we let our u value be the denominator, what's inside the parentheses actually, e to the x plus e to the negative x. Remember your derivative rule for e to the u is e to the u times u prime. So derivative is e to the x times 1, and then e to the negative x times negative 1. And this we can simplify by making this e to the x minus e to the negative x, because this negative 1 will make this e to the negative x in front a negative. So if we solve for dx, we get du over e to the x minus e to the negative x. Okay. Now the nice thing about what's produced from the derivative is that this will cancel out nicely with the numerator of our original problem. Okay. But slight change, slight adjustment is we have to factor out a 2 so that it will cancel out cleanly. So factor out a 2 from the numerator, we get e to the x minus the negative x. Okay, we cancel out the binomial here, or these two terms. And once they cancel out, we get the integral of 2 over u squared. And we got to be careful here. This is not going to be a natural log rule. Natural log rule would be for 1 over u to the first power. But if it is u to any other degree in the denominator, we have to make adjustment and go through power rule. So u squared in the denominator will only work for power rule if we bring it up to the top. So this becomes u to the negative 2. We go through power rule, u to the negative 1 over negative 1, and we clean this up, we get negative 2 over u plus c. And then finally replace our u value back in terms of x. All right, number 5. We have negative sine of x times 3 to the cosine of x dx. Now, if you can look at this problem and see that this is going to be a match for the rule a to the u. So the rule for a to the u is a to the u over natural log of a plus c. So our a value is 3. Our u value is the exponent, cosine. So we go through that. U value is cosine. Our derivative is negative sine. Solve for dx, we get du over negative sine of x. Make our substitution. Negative sine x will stay initially, 3 to the u, and then dx gets replaced with du over negative sine of x. The negative sine of x cancels out. We're simply left with the integral of 3 to the u du. And the rule is simply 3 to the u, so the original problem, divided by natural log of a, so natural log of 3 plus c. Okay, finally, replace your u value back in terms of x. So 3 to the cosine of x over natural log of 3 plus c. Okay, let's look at number 6. 8 over square root of 4 minus x squared plus 2x. Okay, so the hint here is to complete the square. Now, to complete the square, we're going to have to deal with this x squared plus 2x. So I'm going to just deal with the denominator for now. So 4 minus. Now, if I want to factor, I need this x squared to be positive. So I'm going to pull the negative outside. But what that means is every term is going to have to change sign. So positive 2x becomes negative 2x. And then we do plus space. Now, this plus space is really a negative because there's a negative in front. So because this is a negative value, I'm going to have a plus space as well. So these two values will cancel out because this is actually, once we distribute, this will be a negative value. So to find that value, it's b over 2 quantity squared. Our b value is 2, or negative 2. Negative 2 over 2 is negative 1. Negative 1 squared is 1. So we put 1 in the spaces and we factor. So this becomes x minus 2 quantity squared. and then the 1 we can combine with the coefficient, with the 4 out in front, so 3 minus x minus 1 quantity squared. Okay, this is the form that we want. Okay, this is the form that we want, 3 minus x squared minus 3 minus x minus 1 squared. We don't want this x minus 1 squared as the first term, because in order to match up with the appropriate arc trig rule, the first term is always positive. So we're going to make the constant positive, followed by the x minus 1 squared. So if we put this back in its place, we have 8 over square root of 3 minus x minus 1 squared. Now, because the constant is the positive term, this will match up with the arcsine rule, okay, because we see the square root here. This will not be the arcsecant. Arcsecant would mean that the u value is the positive term. So since this is dealing with the a value, we want to get this to the correct form. So we have the parentheses in place, squared. So 3 becomes root 3. X minus 1 doesn't change, stays as x minus 1. Our u value is x minus 1. Our a value is root 3. Our derivative, du over dx, is 1. So we start plugging in. 8 is a coefficient we can pull in front. Square root of a squared minus u squared. And then dx gets replaced with du. So this is going to be a clean arcsine rule. Pull the 8 in front. The rule is arcsine of u over a plus c. So therefore 8 arcsine of x minus 1 over root 3 plus c. All right, number 7. Make sure that you are able to recall the 4 new trig rules that we learned and integral rules that we learned for trig. And one of them is cosecant of u. And the rule for cosecant of u is negative natural log of cosecant of u plus cotangent of u plus c. Okay, so if we're going to match it with that form, then we should be able to pick out the fact that the u value is 1 minus 3x. So u is 1 minus 3x. Derivative is negative 3. dx is du over negative 3. We make our substitution. So integral of cosecant of u. dx gets replaced with du over negative 3. We pull the negative 3 in front as negative 1/3. So now we can simply apply the rule. So cosecant of u becomes negative natural log of cosecant of u plus cotangent of u plus c. The 2 negatives cancels out. We can just have a positive 1/3 and then replace your u value back in terms of x.